Welcome to this discussion about the attributes and analysis of functions, including their graphs. And in this video, we're going to look at how do we identify functions and their domain and range from a set of ordered pairs, or how do we identify functions given an equation. So we're looking at an equation, we want to decide whether or not it represents a function. So we're going to get started. All right, so let's talk a little bit about what is a relation, okay? We talk about this mathematically as a set of ordered pairs, okay? So we are relating two things in some way, but the relationship does not have to be mathematical. You could have a set of ordered pairs that relates a jersey number from the Atlanta Braves to the last name, but there's no mathematical association there, right? So a relation does not have to have any kind of mathematical association. The domain of a relation is a set of all input values. Okay, so whatever I'm putting in to get the other piece out, that's the domain. And now if I'm talking mathematically, I'm usually going to be talking about x values. Doesn't have to be. If we're talking about things that are related to time, we might use time as an input. We might use quantity, n, as an input. But most often in math, we use x as our domain values. Now, the range of a relation, that will be the set of all output values, and this is usually y. Now, a function is nothing more than a special relation. It's a class of relation, and what's special about it is for every input value, there's exactly one output value. Okay, so we deal with functions all the time. You deal with them so frequently you don't even know it. For example, when you go to the gas pump, you are buying gas as a function of the quantity of gas that you pump, right? That's why we have a sign outside that says it's $1.57 per gallon. So I know to expect that for every gallon of gas I put in, I should end up paying $1.57. That's a function, okay? If it was more like I'm putting in 10 gallons and I have no idea what I'm going to end up paying, I could be paying $15.70 or $157 or $72.93. You know, that would not be a function because I don't have a specific output for that one input. So when I'm looking at a set of ordered pairs, I want to make sure that if it's a function, each x value is paired with exactly one y. Okay, so let's look at an example of this. Here's a relation. A relation is, like we said, a set of ordered pairs. So this ordered pair is 3, 4, 4, 4, and 5, 7. So first, what is the domain? Well, what is the set of the input values? And you can identify all these first things in our ordered pair. So 3, 4, and 5 would be our domain. Now our range is going to be all of the output values. So I have 4, 4, and 7. But I don't have to list 4 twice. I can just list it once. When we use those curly braces, all we're doing is having a list of numbers. It's like a shopping list, okay? So if you had 2 recipes that both called for milk, you wouldn't put milk on your grocery list twice. You would just put it there once. And it's the same kind of thing here. Now, we want to know if this is a function. So I look at my input values. Is 3 as an input value paired with anything other than 4? Well, no, because it doesn't even occur more than once. How about 4 as an input value? Is it paired with anything other than 4? No. How about 5? No. And so we can say definitely it's a function because no input value is paired with more than one thing. You can think about it as your X values are monogamous. They are not messing around with anything else. Okay, for this next task, we want to be able to look at a function and determine whether it represents y as a function of x. Okay, so the very first thing you're going to want to do is solve for y. We want to isolate the y value so that we can see what kind of outputs we're going to get whenever I put something in for x. Okay, so we can only do that if our y value has been isolated first. Remember, how many outputs should I get for a function? I should only get one output if it's a function. So before we actually do this, I want to just remind you that when you are isolating a variable by taking the square root or any even indexed root, which could be a fourth root or a sixth root, remember that you are finding all values that satisfy the equation, and so we must remember to utilize plus or minus there. Okay, that's only when we have even indexed roots. So let's look at this first example. If I want to solve for y, I need to get this y isolated, which means I need to take the square root of both sides. And I need to remember that I need a plus or a minus on this other side. Okay, so I know that y will equal plus or minus the square root of x. So now I want to think to myself, okay, well, how many outputs do I get? Well, for every x value I put in, I get 2 outputs out because of that plus or minus. So this does not represent a function. Let's look at this next example. X plus y cubed is equal to 27. Okay, well, let's solve for y. First thing I would want to do is subtract x. So y cubed is equal to 27 minus x. And then I would want to isolate the y by taking the cube root. Now notice cube root is not an even indexed root. So I don't need plus or minus here. So I would just say the cube root of y cubed is equal to the cube root of 27 minus x, or y is equal to the cube root of 27 minus x. And notice that whatever I put in for x, I'll only get one output. So therefore, this is a function. Okay, that's it for this video. In our next video, we're going to talk a little bit about how do we recognize functions from their graphs. We're also going to talk about evaluating functions, and I will see you then.